So questions?
I have a question for Sahil, actually.
No, I was about to say. Yes.
Yeah, so I like where you've taken this. Your thinking on it has obviously evolved in, I think, a positive direction. Is the marketplace that you're envisioning and the agents and that structure, does it necessarily have to be tied to sharing bare metal? Why couldn't you do it with containers or capacity or VMs or some other unit?
The reason why I'm focusing on bare metal is because I want to support clusters that may not be feasible for using containers or virtual machines. Like, for example, I want HPC to participate. I want researchers who are developing new systems and may not be able to deploy their systems on bare metal or would want their own system on bare metal, would want to participate. Pardon?
So I think Hugh's question wasn't, why are you doing this with bare metal? Nothing exists with bare metal. This seems like a good thing to do with bare metal. The question that Hugh was asking was, could this model be applied at other layers?
Oh, yes, certainly. So yeah, the idea was that FLOX used to be an abbreviation for the first layer of Open Cloud Exchange. So I'm certainly wanting it to be repeated at the other levels also, yes.
I think that I would sort of question that a little. So I wouldn't disagree with that, but the thing is that we've already seen, I mean, Mesos in some sense was creating a model where they did offers to different things and they added frameworks that, and frankly, Mesos has lost to Kubernetes, right, which is a much more rigid structure that has a global scheduler, right? So I don't think it's worth making the investment to try to undo that, even though, frankly, I like the Mesos model better than, but I do think that this is a green space where nobody's done anything. And in fact, it's critical. So focusing on this space makes sense.
Thank each of you for your presentations, which I enjoyed. I'd be happy if you each shared just the one most difficult aspect that you found, the hardest part of each of the projects that you pursued. And it could be something very simple, like porting some software that you thought would be easy. Just tell us one thing about your project that you found perhaps harder than expected.
So, there were actually a lot of different exciting parts, and exciting means that I did not know the answer to it, and hence exciting because I had to find out. One was I had to go out and learn about economics, about market mechanism, about incentives, how trade markets work. And I think the difficulty was positioning, like when you're trying to make something new, you always try to find an association with something that is existing already so that you can know that, how different this is. And that was a learning experience for me to understand that where does FLOX fit in? Is it a stock market? Is it an Uber model? Or is it a commodities market? How does it look like? And that took me in a path which was not computer science, but more economics and that was a fun journey that I relished doing that.
I think apart from convincing people to give their traces, that was like one of the biggest challenges was to convince them, and the data is not clean. You have to look really carefully in the data, whatever is available publicly.
For me, it was trying to get a bare metal kernel booting on the MOC that's customized for your own, and then figuring out how to write a device driver from scratch by reading Linux source code and also the data sheets, which are kind of not well documented.
I think for me is one of the difficulty is like caching is well done studied area in research. So doing something works and as an actual system and supports a lot of different applications. And at the same time, trying to come up with a novel idea was difficult. Also, I believe like Ceph code is very difficult to debug and implement everything. There was almost no command in the code. But overall, I think I was like trying to build an actual system which everyone's can able to use it, but at the same time, I'm trying to come up with some unique or novel ideas. I think that was my challenge.
I think for me, the greatest challenge was deploying my auto-tuning technique in resource-constrained environments like power cap situations, or even in very large-scale systems like in clusters with thousands of nodes.
All right, so if you remember, my talk was about how to address the problems in productionizing AI. To me, if you can define a problem properly and formulate a research problem, you solve half of the problem already. So to me, we have to figure out, we see there's a gap in reality, so we had to do a lot of work in talking to customers, understanding their pain point. We need to investigate the current technologies to see where the gaps are, right? And with that, how you can define the research problem and come up with a solution strategy. I think that's the most difficult part.
While he's walking up, I guess, Huya, you stated there'd be this grand vision of all these components kind of flowing together, which seems extremely compelling, but it also seems like each part of that is itself, just even from the mechanics perspective, creating the platform before you can even start approaching any of the research problems you alluded to seems like an enormous effort. Is there any frameworks out there like this, open source frameworks that we could start going for? Is this a grand vision or is there a project you guys plan on releasing, or where is that?
Okay, those are too many questions. So we're not starting from scratch, right? If you remember, I talked about there are 3 pipelines: data pipeline, model pipeline, and insight pipeline. For the model pipeline, there's a lot of integration work already that in the form of machine learning platforms. In the data pipeline world, there's also a lot of things we can leverage because people have been talking about data fabric, which is effectively is a way to integrate different data tools together. So what's missing actually is, can we do something similar for insight generation? And then how can we tie these 3 silos together at a higher level? So it's not as difficult as one might think. Make sense?
So my question's along the same line, which is productionizing AI, and from a data lake perspective. And one of the challenges that you had mentioned was data deduplication, as well as the currency of the data, and other considerations for addressing those shortcomings at ingestion, and as you're training a model, deduplicating, and then cross-classification across the data lake itself. And if so, is that a project you're working on, or is there an open source alternative to Oren's question?
So let me first quickly summarize what we're trying to do here, right? First, we see a proliferation of siloed tools out there. We try to bring them all together in the integrated environment because we always believe that the whole is much, much greater than the individual and the sum of individuals, right? That's one thing. And secondly, by bringing them together, we try to simplify the use of individual tools by exposing higher level abstractions. So that's what we're trying to do. Right now, we are developing some projects in this area. Our target is to take it to open source soon, this year. We'll have a good part of the development done already underway. So we are going to take open source sometime this year. We also, obviously, there's only so much we can do within one company, right? We'll be happy to partner with other companies to advance this in the open source context.
So we offered a deep dive on running OpenStack on Cloud Lab. That is actually still going on because provisioning nodes and all this stuff, as most of you know, takes a little bit of time, and it's new for some of the folks. So that takes probably took a little bit longer than we planned for, but people are successfully learning how to use, Cloud Lab and provisioning a slice, so to speak, compute their networking hardware to run their experiments in this specific case. To run OpenStack on top of it, that's working particularly well. We actually, Rob was still there in the beginning. We could point a small bug out to him. So I think we're also doing some alpha, beta, whatever gamma testing. So that's good. And in the future, people will be able to use that when we have Open Cloud Testbed up and running, where then you can actually use some of the resources via Cloud Lab for your own experiments. So when do we start the second? After the break, there will be actually, we'll do the same thing over again. If you're still interested, please stop by. Thank you.
Good afternoon. We did a deep dive in Birds of a Feather that revolved around enabling researchers and research facilitators using Open Data Hub on Mass Open Cloud. And that was really good. We, as an open source project that started at Red Hat, Open Data Hub really focuses on how to help data scientists be more self-service. And so what we wanted to do is get that feedback from the researchers in terms of what are the tools they're using today and how can we enable them to do their workloads using Open Data Hub. So one of the first pieces of feedback was that they use R and we offer up Jupyter Hub. So that's one thing that we need to take back to the engineers. How do we look at providing things like R and some of the other tools? But then also some of the use cases with, for example, Dataverse. How do we share data where you've uploaded it into Dataverse, but then now you want to use tools like Spark and TensorFlow and GPUs to analyze that data as it sits in Dataverse. So some great conversations from the researchers on how we can continue to push the envelope and really use open source tools in the MOC. And we are going to follow up with a number of people to figure out how those collaborations can happen. Anyone else?
Is there an HDMI? I mean, it's just 4 bullet points. So this is from the FPGA Breakout, which turned out to be the FPGA/Fabric Breakout, which was very cool. So we had turned out there was lots of wonderful synergy, which I guess is also not surprising because the Fabric people are also the Chameleon people, and one of the things we talked about was the limits of each other's systems and who are going to support in what kinds of projects. Another thing was what we had in common, and since the one thing that you never have enough of is support, how we can share support in developing things like board support packages. In other words, different configurations to allow different classes of researchers to work on, well, as many projects as hopefully we can support. One thing that we're all interested in is P4 and in-network computing, and we thought about different ways to do that. We have very different. Sorry, thank you. I'm used to projecting anyway. That's what I do. But anyway, so oh, thank you. Got it. Yeah, good. So we're up to number 3. So P4 and in-network processing. It's something that we're all interested in right now. The Open Cloud FPGA testbed isn't geared towards this because we stop at the bump in the wire, but it's something we as researchers are very interested in, and also the community that will be using it. So that would be a great thing to think about, at least if not support directly immediately. Of course, we're always trying to do everything, but we do have constraints. Have an the FPGA testbed bump in the wire link to Fabric. Okay, so now we're starting to talk. So let's say that we wanted to do the bump in the wire, and we should be isolated because we're part of the Open Cloud testbed, but yet Fabric seems to be, if I understand this right, destructible, and so it means that there is potentially a way to couple these, which is just mind-boggling. It's to be able to really do cross-network experimental things from the node through the bump in the wire through the network sounds amazing. And the last point was that I'm not going to overplay this, but We have not taken as much advantage, for all the excitement, we have not taken as much advantage as we potentially could for industry collaboration, if I put it that way. Thank you.
All right, so Michael told me that I didn't need slides, and then of course I go after the perfect presenter who brought slides. So we did a birds of a feather session on the Open Infra Labs that talked about some of the goals and the structure and the community engagement. And I think that we are going to be moving that discussion and continue it on the mailing list. Go to openinfralabs.org if you want to join in and participate on that as we finalize it. The basics that I think we were kind of coalescing towards is something where we look to have Open Infra Labs code repositories host things like configuration and deployment artifacts. Those might be Ansible playbooks or Puppet scripts, things that take open source software and manage the deployment and configuration of that, as well as trying to put together a set of reference architecture documents for different layers of these cloud environments. The NERC is the initial kind of target production goal for the output of those, and so working closely with the owners of the NERC to help kind of filter and I guess kind of you could say trim down what the targets and the versions of different software components are, so that we can come up with something that's stable and reproducible. Let's see, what else? Did I miss anything? Any of y'all who were in that session? Yes, Bill? Yeah, so there were several kind of types of components. We talked about life cycle, so deployment and upgrades. We talked about monitoring, talked about resource allocation, and then resource accounting. And I think those were the four categories. So those are the kinds of things that we'll be working on. And I think the other thing that we agreed on was that the shortened form of Open Infra Labs will not be OIL, but OI Labs instead. We don't want to have oil inside of the green data center facility. So go to openinfralabs.org and join the list and help us continue the conversations. Thanks.
Hello. We had a birds of feather discussion about monitoring, and we talked to like what are the constraints when you have monitoring in an HPC cluster. You have to keep the size of the agents very small and such. And we talked about how we do monitoring in OpenStack clouds and all. And in most of the discussion, we realized that Prometheus seems to be one of like a really good thing we should to take a look at. At the moment, we have been using Zabbix, and we were planning on using Prometheus anyway for OpenShift. And given VexHost's experience with Prometheus for monitoring thousands of hosts, and the fact that it already has a bunch of exporters for like OpenStack monitoring, libvirt exporters and all, it might make sense to give Prometheus a second shot at it. So that's what we plan to, we're gonna look into it, and then we'll have more discussions with the rest of the teams as we make some progress. That was pretty much it.
Hi. So we had two different BOFs on ESI, Elastic Secure Infrastructure. Since there was 100% overlap in people who are interested in them, I'm going to report on them both. If you look in the agenda for the workshop today, there was a link to a Google document for sharing information from the BOFs, so we actually put stuff in there. So if you want to see more details about what we discussed, please go to that link. Even though it's crossed out, it's still valid. It's just crossed out to show that we had it. We basically discussed 3 things. One was an update from Lars and Min, who've been the main developers on the ironic changes that we've been feeding upstream in order to enable ESI. So there's a link to their presentation there and their emails in case you want to ask them more questions about that. We then discussed what other things would be needed for ESI, since we had Julia Krager there. Thanks for coming. The voice of all knowledge on ironic, and what things we might need to add or what things might or might not work. And she was looking things up dynamically on her phone while talking, so I was very impressed. And that was a good discussion. And then the final thing that we did was to talk a little bit about, okay, well, we want to lease bare metal nodes, and the first use case is how do we take bare metal nodes that are sitting in the MOC and allow Cloud Lab to come in and lease them so that Cloud Lab can provision them and give them to Cloud Lab users to use for experiments, which is fairly complicated. Never mind, you know, the design is complicated, not just the implementation. So we discussed that a bit. It's going to take a while to work through all of that. But Mike Zink said he was going to be able to make some servers in the MGH PCC available so that we can prototype and try out software and do the way you really learn to do these things by building them and breaking them. So I don't have a schedule for exactly when that's going to happen, but if you're at all interested in it, speak to me, or maybe even Julia. She'll probably know when it's happening, and we'll be happy to get you tied in with the project efforts that are going to go on there. Thank you.